So I'm presenting Understanding Gender Bias in AI-Generated Product Descriptions with four Markelle Kelly, Mohammad Tahaei, Padhraic Smyth, and Lauren Wilcox. And I'm Jacob Metcalf. All right. E-commerce platforms like eBay increasingly use generative AI in product listing and review workflows. So for example, when a seller is posting an item for sale, one Gen AI feature includes auto-generation of an item description. More concretely, when a seller is posting an item for sale on eBay, they go through this listing creation process where they enter a title and other specific details about the item. So they provide the basic categories, name, is it new, what kind of bike is it, what's the brand. And they also have to provide a description, like a paragraph or two of narrative text, which might provide further information about the product or attempt to persuade the buyers to purchase the item. On eBay these days, there is a Use AI Description feature on the bottom right, which provides sellers with an automatically generated description based on the title and the other input information. So sellers can then edit this description if they choose to before ultimately posting their item for sale. So this and other e-commerce specific applications haven't received a lot of research attention in this community. In particular, we don't have a good idea of where this can go wrong, i.e. what harms and biases can show up in this setting or in this specific setting at eBay or related e-commerce settings that might have similar tools. eBay in particular makes use of an internal in-house LLM, and also I believe at the time of this study was using ChatGPT 3.5. If that detail really matters to you, double check it in the paper though. All right. Yeah, there we go. Our work aims to address this question, investigating what bias looks like in AI-generated item descriptions. In particular, we develop taxonomic categories for bias, identifying issues that are unique to or manifest differently in this specific setting in e-commerce. We then quantitatively evaluate two LLMs that were previously used at eBay for this task in the context of these taxonomic categories, gaining a better understanding of how common or visible these issues are in practice. So our findings regarding this particular application of description generation have implications for a broader class of AI applications. The work is the first, to our knowledge, systematic investigation of how bias shows up in the use of Gen AI models for e-commerce. This is important because 1, e-commerce platforms have material impact on those who rely on them to sell goods. 2, e-commerce intersects with and shapes culture and group identity. And 3, e-commerce platforms, by their networked nature and prominence, can serve to amplify biases introduced by AI. So, challenges for the study. How can we identify task-specific taxonomic categories? Our first step then was to come up with a process for identifying the taxonomic categories. There are a couple trade-offs we needed to be mindful of in doing this. So we wanted to be able to leverage existing knowledge and extended general purpose taxonomies for bias, many of which have come out of the FACT community, but we didn't want to be limited by the scopes of these taxonomies because they were largely built around evaluating different purposes. And we therefore wanted to cast a wide net, potentially identifying issues that are unique to this space or use case, or fall out, and therefore might fall outside of these existing frameworks. We have a big data set of real descriptions to evaluate, right? So drawing on, I think it was an N of 10,000 examples of real descriptions that were generated by this tool. We wanted to cover as much of those as possible, identifying even rare issues, but we also wanted to take in a close, in-depth look at specific issues. So there's sort of a breadth versus depth question at the heart of this research methodology. So to satisfy these trade-offs, we came up with a 4-step taxonomy development process, and we'll quickly walk through each of these phases. The first step was to identify overarching themes of bias as established in existing general purpose harm taxonomies. In the paper, of course, they cite the 4 or 5 harm taxonomies, again, most of which come from fact scholarship, in existing general purpose harms, so not focused on e-commerce. So our work will extend these frameworks, allowing us to leverage this valuable prior knowledge on forms of algorithmic bias. We'll focus on 3 particular bias themes. So first is exclusionary norms. Exclusionary norms. So those are expressions of what is normal or typical that might implicitly exclude certain groups. That is any kind of statement that might lead to a certain social or demographic group feeling left out or excluded, which in the context of e-commerce would mean thinking that such and such product is not for them, even if it could very well, be used by them or fit their body. Second is stereotyping and objectification. So these are generalizations about particular groups of people, including an unwarranted focus on physical appearance or sexual appeal. So this might be associations between groups of people and roles, traits, behaviors, occupations, etc. We include a special emphasis on sexual objectification here, as this is an issue that has historically been particularly relevant to advertising and marketing, which would be sort of the linguistic corpus that these models would be drawing upon. And last is disparate performance. So this would be degraded quality, diversity, or richness of generated text for certain groups. So this category covers any disparity in text generated for different groups, not just faithfulness or coherence, but also diversity, tone, level of detail, etc. So basically, how good is the description at accomplishing its task, and does that differ given the potential biases within the model? Okay. So using an analysis data set of 10,000 real descriptions generated for sellers on eBay, our next step was to identify a potentially problematic set of these descriptions for closer review. Right? So we've got an N of 10,000, we need to figure out which ones in there are problematic, and then bring those under closer scrutiny in order to build recursively build another taxonomy. To do so, we use both human and automatic flagging processes. Our annotation guidelines were based on top-level bias themes, but annotators were also encouraged to look for other issues not strictly related to these themes. As a result of this process, we ended up with about 120 descriptions to look at more closely by more expert reviewers. We then had expert reviewers take a closer look at each of these flagged descriptions. These experts were individuals from DEI and AI red teaming at eBay, with backgrounds in psychology, social justice, and machine learning. Our guidelines for this process were still grounded in the existing overarching themes, but solicited more open-ended, long-form comments on the problems or behaviors exhibited in particular generated descriptions. And then finally, taking those more detailed descriptions from the expert reviewers, they then synthesized these reviewer comments into our final taxonomic categories. We found that by and large, the most common type of bias identified was gender bias. Thus, in our taxonomic categories and corresponding evaluation, we focus in particular on gender bias. In that context, we grouped closely related issues that reviewers highlighted into 6 taxonomic categories, each representing a different type of bias. There were other forms of bias that they found in this generated text, but by far the majority was gendered bias, which in some ways makes sense, right? A large part of the corpus here is about clothing, right? So already the text has a lot of gendered language in it, but then also advertising tends to be highly gendered in a way that perhaps other kinds of commerce might not be, and therefore the richest amount of analysis was available when they focused just on gender, even though there were a small handful of other forms of bias that were available. So we situate our 6 taxonomic categories with respect to these 3 general themes of bias established from the existing frameworks and introduced earlier. And found that each category falls under one of our general themes. In this way, our 6 taxonomic categories create an important application-specific extension of these existing harms frameworks from the literature, There are a lot of interesting issues discovered in the analysis, which you can read more in depth in the paper. But for the sake of time in this presentation, we're just going to explore one particular taxonomic category in depth, which is bias in advertised features. So the basis for this category was a number of reviewer comments highlighting systematic differences in the descriptions for men's and women's clothing items, particularly in how these items were advertised and what features or qualities they were associated with. More specifically, reviewers observed that women's clothing descriptions tend to emphasize how the person wearing the clothing will look and imply that attracting attention is an important goal of the wearer. In contrast, reviewers noted that men's clothing descriptions tended to advertise qualities of the item itself, such as comfort or durability, and associate the item with how the wearer will perform in some activity while wearing them. Right, so we have sort of the classic passive versus active dichotomy in describing gender roles. And so to better isolate the role of model behavior here, right, versus just differences in distributions of clothing items for men or women, right? So that it might be that there's a lot more women's clothing for sale on eBay than men's clothing, and that could throw it off. And so the goal in this next part of the exercise is to isolate that potential dynamic from the role of model behavior. They curated a set of counterfactual pairs which differ only by the associated gender, right? So for the example above, we have a pair of boys' jeans, right, with a specific name and size, and then the exact same name and size for girls, and then generated a large number of descriptions for each of these inputs using the model that they were going to evaluate. And it clearly generated quite distinct descriptions fitting that dichotomy between passively looking attractive and actively accomplishing something for boys and girls' jeans. To assess whether there are systematic differences between the resulting pairs, we then were interested in whether we can predict which original input a certain description came from after masking the gender-specific term. So if you then masked boy and girl, could you then predict retroactively whether that was a description of a boy's item or a girl's item? And the answer is yes. In general, with over 95% accuracy, even hiding the gendered term, one could predict whether it was describing which gendered item of clothing was being reflected there. So, with very high accuracy across all 50 counterfactual pairs that they worked with, even using only a simple bigram-based classifier. So this reflects that the model is describing the same item very differently, simply depending on which gender is associated with the item. Which words were most predictive of each version? We identified these. We can take this a step further and look at which specific words are most predictive of the gender associated with an item. For the jeans, we see that words related to durability and activity are associated with the boys. Words related to style and fashion, as well as appearance, are associated with the girls. Terms like silhouette suggest a lean towards objectification, especially concerning that these are jeans for children who should probably not be sexualized in that way. And so we identified these 6 taxonomic categories. For more info on the other 5 categories, see the paper. There's the QR code to the archive version. Beyond understanding and quantifying bias in this particular setting for 2 particular models, this work also provides a template process for understanding the forms of bias and harm at play in other specific generative AI applications. That's all. Thank you.